Okay guys, here we are back with, we're simplifying trig functions, and this is just another way to do it, or an option that you have whenever you're faced with a problem. This is still 5.1 continued, and it's simplifying by factoring. So what you want to do is always look and see if there's something that could be replaced with something easier or a smaller identity, or if you see something that has been an identity, then you want to look at it and say, hey, I can replace that with something, and we'll see if that gets us anywhere. A lot of this is just guess and check. Try it. If it doesn't work, then try something else. That's where you're going to get frustrated, because there's not really one way that I can tell you to solve every single one of these or start every single one of them. So first thing I'm going to notice right away is that we've got this right here, this sign of pi over 2 minus x. So this has to be a minus, this has to be pi over 2, and this has to be either x or theta. And that is an identity. We can replace the sign of pi over 2 minus x with its cofunction. So what we can do is rewrite this as sine squared x cosine x minus, that's an identity. Just look on your papers or the notes that you've taken. That's the same as cosine of x. So we've got that a little bit simpler already. Next thing I'm going to do is look at my two terms. Remember, this is one term, this is another term. Terms are separated by pluses and minuses. So I'm going to see if I can factor something out of both of these just to make it simpler. So this term has a cosine, and this term has a cosine. So let's go back to Algebra 1, and we're going to factor the cosine out of each term. So I'm going to factor a cosine out here. If I factor a cosine out of this term, right inside the parentheses, I'm going to write what is left over. Well, if I factor that out, then I just have sine squared x. Then I go to the next term. I'm going to have minus. I factored out a cosine. I pulled it out here to the front of the parentheses. If I take an entire term out, you replace it with a 1. So now we've got cosine x times sine squared x minus 1. That's almost an identity. Remember, if you've got a function or a trig function that's squared and you've got a 1 in it, then that's probably saying, hey, look at me, I'm probably an identity. If you go back to your identity of sine squared x plus cosine squared x equals 1, you can see that if we subtract sine squared from both sides, we get 1 minus sine squared x. That's the exact opposite of what I have right here. I need my sine to be negative and I need my 1 to be positive. Well, if I factor out a negative 1 here, I can make that a negative 1 plus sine squared x. And now I've got this right here. It's just written in a different order. So then I'm going to divide both sides by this negative 1, and I end up with negative cosine squared x equals negative 1 plus sine squared x. So now I can replace this whole set of parentheses right here with negative cosine squared x. So I'm going to have cosine x times, all of this is being replaced with negative cosine squared x. And now these are multiplying terms. I'm not adding or subtracting. So if I have the same trig function times that trig function squared, that's just going to get me a negative cosine cubed x. So there's your answer. And again, you're just simplifying it. Instead of writing all of this garbage, you just replace it with this. Okay, it's what it can be replaced with. It's just like simplifying a great big fraction or a complex fraction. You get it to the simplest form. This is the simplest form that this can be written in. So let's do another example like that. So let's do negative cosecant x. Nope. x, negative cosecant, and then this is pi over 2 minus x. So already I'm thinking, well, that's pi over 2 minus x. That's probably going to be able to be replaced with something. And then minus tangent squared secant. So minus tangent squared x secant x. So again, I've got to simplify this. I want to get it as simple as possible right off the bat. So I know that this right here, without that negative sign, is an identity. That's one of the cofunction identities. Again, you've just got to have all of these sitting next to you so that you can go back and look them up, or memorize them all and keep looking at them, keep working with them so that you get really familiar with them. But these are cofunctions. So if I have a cosecant, then the cofunction for cosecant is secant. So that means I can replace this with secant x. And I still have my negative sign out here. I didn't do anything with that. So I have negative secant x minus tangent squared x secant x. And now, we want to simplify. Well, what in the world can we do? Well, I'm just kind of looking at it. I can see that here we have a secant, and here we have a secant. This is one term. This is another term. Terms are separated by a plus and a minus. So what we can do is factor out that secant of each term. So I'm going to factor out a secant. What does that leave in this term? It leaves a negative 1 because you took the whole term out except that negative sign. And then we have a negative tangent squared x. So I pulled that secant out here. Since these are both negative, it probably would have been better to just factor out a negative secant squared. It doesn't matter if I do it now or if I wait till I get down here to this point. So I'm going to factor out a negative. So that's going to leave a negative secant x. That's going to make this a 1 plus tangent squared x. Now, you've got a 1 and you've got a trig function that's squared. So what is the trig identity that deals or has 1 plus tangent squared x? That is secant squared x. So, and that's just looking back at your identities again. You just need to be thinking, okay, if I've got a minus and a pi over 2, then that's probably a cofunction. If I've got a 1 and a trig function squared, probably a Pythagorean identity. So this whole thing can be replaced with secant squared x. So now, if I do that, I have a negative secant x times secant squared x. And I multiply a secant times a secant squared. That's going to get me a secant cubed x. And don't forget, we still have this negative sign out here. So there it is. And you have to factor this negative out because I don't have an identity that has a negative 1 and a negative trig function. This is a positive with the tangent and a positive with the tangent. So I'm looking at my Pythagorean identities. I need both of those to be positive, so that tells me, hey, I need to factor out a negative 1. So there you have it. That is factoring.